In this project, steel piles were proposed. Steel piles are one of the common type of pile used for structure foundation. Various shapes of steel piles are available, such as round, square, rectangular section, as well as steel tubes. Steel pile diameter used for this project were of diameter 711 mm with thickness of 16 mm. These piles are subjected to various load conditions such as bearing stress, lateral pressure, as well as bending moment. The capacity of this pile depends on soil properties, pile dimension, and the type of loading applied. Pile bearing capacity calculations. Piles are one of the main elements of a structure system. Special care is needed to be given in deciding the correct piling system to ensure structures are stable. In this video, we are going to go through a simple calculation to determine the pile capacities. The structure used for the example is a small concrete jetty that was constructed near the shoreline. We carry out in the project area. Example of bow locks is indicated in this slide. Detail of the soil profile is captured here. You can see that the first depth 0 to 5.5 meter is not indicated as the ground is not that good. From depths of 5.5 meter to 7.5 meter, the ground is made up of silty sand and loose sand. From 7.5 meter to 10.5 meter, soil is sandy silts and is very soft. From the depths of 10.5 to 12, this clayey sand. 12 to 13.5, sandy silts. 13.5 to 18, medium dense silty sands, and 18 meter to 19.5 meter, the ground is made up of silty sand. The formula for the calculation of pile bearing capacity is shown here, where the bearing capacity of pile under compression load is a combination of the end bearing and positive friction along the pile shaft. The ultimate end bearing and ultimate positive friction shall be calculated using this formula, where QD equal to QF plus QP. QF is the unit friction capacity multiplied by the side surface area of pile, whereas QP is the multiplication of the unit end bearing capacity multiplied by the gross end area of the pile. In the case of open-ended pile, a prediction shall be made to determine whether the pile drive in the coring or plugging mode. Next, we are going to talk about the shaft frictions in cohesionless soils. For tubular piles in cohesionless soil, the shaft friction F may be calculated by the following equation. F equal to 3 divided by 4 multiplied by K, which is the earth pressure coefficient, and multiplied by PO, which is effective vertical stress, and multiply by 10 of the angles of internal frictions. For this calculation that we're going to go through, the K value of 1 will be used. However, the ultimate positive friction shall not exceed a maximum value of 120 kPa. The phi value used in the calculation are determined based on the correlations with the SPT n value. It is tabulated here where the n value is less than 4. The angle of friction, internal friction, will be between 25 to 30, and 4 to 10, the angle of friction is 27 to 32, and so on. The phi value used for the calculation of the skin friction is obtained from the following tables. The n value are obtained from the Bolog's data gathered from the soil investigation, as shown in column indicated here as PT n values, and the more detailed description of the soils is shown here. For example, for soil strata 1, the n value is 0 for very soft dark greenish grey sandy silts, and strata number 4, n equal to 17, where the soil description is stated as mediums, dense dark grey silty medium to coarse sand with traces of gravel and decay wood. Maximum penetration length. For skin friction, Tomlinson's recommendation is considered. The maximum penetration length for skin friction is limited to 20 times the pile diameter. Thus, L max equal to 0.711 times 20 equal to 14 millimeters. Based on pile set termination criteria, maximum attainable depths in the decomposed granite layer or very dense sand layer, it is considered that the plug will be formed at the pile tip, so that the end bearing area can be taken as a total of steel pile and inside the soil area, where A equal to pi divided by 4 times 0.711 squared equal to 0.397 meters squared. Based on the information explained earlier, we can form this table shown here and do the calculation to obtain the overburden pressure for various depths of soil. From here you can see the depths of 7.5 meter. The overburden pressure is 9 kilopascal and the skin friction is 16 kilonewton. You can continue doing the same calculation for depths of 10.5, 12, 13.5, 18 and 19.5, applying the appropriate values based on the soil properties, and from this calculation we can get the total overburden pressure of 137.25 kilopascal and the skin friction total of 973 0.46 kilonewton. We can then use the value calculated earlier from this slide. You can calculate the skin friction equal to 973 kilonewton. So the ultimate end bearing pressure is Q equal to P0 times NQ, which is 137.25 times 200. So we obtain the value of 27,450 kPa for the ultimate end bearing pressure, but we are limited to 11,000 kPa as mentioned earlier. The end bearing value is calculated based on QP equal to Q times A, where Q is 11,000 multiplied by 0.397, and we get 4367 kilonewton for the end bearing. The ultimate bearing capacity for compression is QUT equal to QF plus QP equal to 937 plus 4367. So the total value is 5340 kilonewton. We're not going to discuss on the tension capacity in this video. So that is the way how we calculate the ultimate bearing capacity in compression for these steel piles.